Hello everyone and welcome back to another problem of the day, and today's problem is titled Move all zeros to the front of the linked list. In this problem you are given a linked list and your task is to move all the zeros to the front of the linked list, and the order of elements except 0 they should be maintained, and they should be maintained after the rearrangement. So for the example, just a heads up, these examples that they have given are not correct according to the output they have given. For the correct example, you can refer this linked list which contains the value 04050211010, and on moving all the zeros at the beginning we'll have the output to have the nodes in this order. Similarly, for the next example, which has the nodes 11230000, we have the answer to contain the nodes in the arrangement 0001123. Now, in order to solve the problem, let's take in an example. Let's say I have 0 1 0 2 3. Now there are two ways through which I can solve this problem. One is using a DQ, one is using a simple DQ, and using this DQ what I'll do is I'll traverse through every node in the linked list, and every time I encounter one I'll push that node. Encounter a 0, I'll push that 0 at the beginning of the DQ, and every time I encounter a non-zero node I'll push it at the end. Using this I'll be able to maintain the order of the elements, and then I'll simply pop the DQ from the front and create a linked list for the required arrangement. Now this approach requires us to use a DQ, which is something that we want to avoid. So in order to use it without using any other data structure or auxiliary space, what I can do is I can simply have two pointers. Let's say the first pointer is previous, which is pointing to the head currently, and the next pointer is let's call it temp, which is pointing to the next of previous, that is the head's next value initially. So the idea here is that we'll use this temp pointer to find any node which contains zero value, and every time we have a zero value we'll simply shift that zero value or point that zero node to the beginning of the linked list. Now let's go through this algorithm, and using this we'll solve the problem. So let's say our t is pointing initially at 1 here, so we need not worry, we'll simply move our t and p to the next node respectively. So p would be pointing here and t would be pointing here. Now after this is done, now I can see that temp is currently pointing to 0. Since that this is the case, I'll use in another node c and mark its value to be temp. So c would be here and temp would be here. I'll move temp one step ahead. Now I have the current node which is marked by c, which is 0. I have to place it at the beginning of the linked list. So in order to do that, I'll simply call c's next to be equal to head. After doing this, I have to maintain the order for p as well, right? So I'll call p's next to be equal to temp, and since we have modified our head would now have the value current. After performing these operations, our linked list would be modified to 0 0 1 2, where this 0 is the 0 that we encountered, and this 0 was the 0 already present, and a p is pointing here now and t is pointing here now. Also we have another element 3. Moving on, now again we'll make a check. Since t is not equal to 0 here, we'll simply move our p and t ahead, one step ahead. So p would be here, t would be here. Let's say I have another 0 over here. Now again, since t is not equal to 0, we'll again move our p and t one step ahead. So p would be here, Now t would be here. Now since this is the case, again my t is now equal to 0. So what I'll do is you make use of another variable similarly like discussed before. So I will make use of c, point it to the t currently, move our temp pointer ahead one step. So since there's no other node ahead, it will be pointing to null. Now point the c's next to be equal to heads value. So and after doing that, we'll simply point our next value of previous to be equal to t, which is null in this case, and we'll reinitialize ahead to have the value c. So the resultant linked list would contain 3 zeros at the beginning and 1, 2, 3 at the end. So using this approach, we'll be able to solve our problem much more efficiently without any use of extra space. So let's jump right onto the code. First of all, we'll make a check if our head is null. Since if that is the case, then we simply have to return the result as it is. After doing this, we'll make use of the pointers as discussed, wherein the temp pointer was pointing to the next value of head, and we had another pointer previous, which was initialized to, which is initialized to head. After doing this, we can simply now loop over our linked list. Let's say we have a linked list. We'll loop over till our temp is not equal to 0, because that is a terminating condition as we saw in this example. Now while looping over, we'll make a check if the data held by temp, if it's equal to 0. If that is the case, then we'll simply uh, perform the 4 operations that we discussed. We'll create a current variable, mark its value to contain the node temp, then we'll use that temp and mark its next to be equal to, move the temp one step ahead, so it will be temp equal to temp dot next. Now we'll mark the previous node's next value to be equal to temp. Now what is remaining is to handle the current node. So the current node's next would be nothing but equal to the head pointer, and we'll reinitialize our head to be equal to current. Now after this is done, since this is the case wherein our data was equal to 0, if that is not the case, then we'll simply be moving our previous and temp one step ahead. So previous should be equal to temp here, and temp would be equal to temp dot next. Let's try and compile. Alright, we got a compilation error. What could be the issue? Okay, this should be a pointer, since they have passed the input using 2 pointers. Alright, so that was it for today's video. If you have any doubts or suggestions, you can ask them in the comment section, and thank you for watching.